Composite manufacturing is not like metal machining. Instead of cutting away material, it builds up material layer by layer, combining fibers and resin to create a lightweight, strong structure. Unlike metals, where shaping is done by bending and cutting, composites require careful control of fiber direction, consolidation, and curing to get the strength where it's needed, making the process much more about how plies are laid and bonded than how blocks are trimmed. Hand layup is the classic composite process where skilled workers lay fibers or prepreg sheets into a mold by hand, one layer at a time, and wet them with resin if needed, building up the desired thickness and orientation. It's simple and flexible, making it good for low volume and complex shapes, but it relies on operator skill for quality control, and without vacuum or heat, like in advanced processes, voids and resin inconsistencies can occur. Prepreg refers to fiber reinforcement that's already pre-impregnated with resin and partially cured to a tacky state, so resin content and fiber distribution are controlled before layup. This leads to better quality composites because the resin and fibers are precisely proportioned and oriented. Prepregs are stored cold and laid into molds before curing. They're the backbone of high-performance aerospace parts because they give repeatable, strong laminates when cured properly. Automated fiber placement, AFP, and automated tape laying are advanced composite fabrication technologies where robots place narrow prepreg toes or wide tapes precisely onto molds using heat and controlled pressure, massively improving speed, accuracy, and repeatability compared with manual layup. These systems can build complex shapes with optimized fiber patterns, reduce waste, and scale to large panels like fuselage sections or wing skins, turning artistry into automation for composite builds. After fibers and resins are laid in the right orientation, composites need to be cured. This means applying heat and sometimes pressure so the resin hardens and locks fibers together into a stiff, load-bearing material. For aerospace parts, this often happens in an autoclave, a pressurized oven that squeezes air and resin out while controlling temperature, which yields high-strength, low-void parts. But curing can also happen in ovens or out-of-autoclave systems for varying cost and performance trade-offs. Composites rely on tooling and molds just like metals do, but these molds must hold fiber orientation and part geometry exactly while resin cures. Whether they're rigid metal tools for autoclave parts or softer vacuum bags for other processes. Tooling for composites often includes removable cores, matched metal molds, and sealing systems for vacuum bagging, all designed to hold plies in the right shape so the finished product is dimensionally accurate and structurally reliable. Manufacturing variability is a real challenge with composites because part strength and stiffness depend on fiber alignment, resin content, voids, and cure quality. Small differences in layup or curing can create variability in part performance. So aerospace manufacturers use strict process control, automation, and advanced inspection methods to reduce that variability. Otherwise, identical designs can behave quite differently if manufacturing isn't tightly controlled.